Okay, so that was the hardest one, the one we just did. Yeah, the logs. Okay, polynomial functions is this unit. So let's talk about polynomials. So a polynomial is a function that contains only adding and subtracting with real number exponents. Okay, so x cubed, that's a real number exponent. So for this one, this polynomial has a degree of 3. Where did I get that from? It's the highest exponent. Highest exponent. And the leading coefficient is 1. Because you have 1x cubed. So that's why it's 1. So when you look at this one, the highest exponent would be a 4th degree. And the leading coefficient is 5. Because you have 5x fourths. Okay, so this one, the degree of it would be a 6 because it's the highest exponent. And the leading coefficient would be a -4. And the last one, I'm trying to be tricky. Can anybody figure out my trick? What's the degree on it? It's 2. Okay, I was trying to be tricky because I didn't put it at the front. Okay, it doesn't matter. It's just whatever is there, so then the leading coefficient is 3. Okay, again, even though it's not at the front, it's still the leading coefficient. Okay. Okay, so you have done this. If there's a degree 1, so just an x, you did this graphing in grade 10. So what did you graph in grade 10? What kind of shape? You only did one kind of graphing thing in grade 10. A line. Remember? Grade 10? Slope, y-intercepts, like those kinds of things. So if it has a positive x, if it has a negative x, it would look like that. So the end behavior goes from quadrant 3, negative infinity, into quadrant 1 to positive infinity. Versus this one, you would start from quadrant 2 at infinity. And then you would head towards quadrant 4 going down. The name of this function is what? Linear. The linear function. Graphs lines. Linear relationship. Okay. 2. So x squared. You've done this all of grade 10, or sorry, 11. What did you graph? What was the shape you graphed? Parabola. So if it's positive, parabola. If it's a negative parabola. The name of this started with a Q. What kind of word starts with a Q? What kind of name is this? QU. Quadratic. Quadratic. And the end behavior goes from quadrant 2 positive infinity to quadrant 1 positive infinity. So kind of have a note here. These ends will go in an opposite direction, but these ends would go in a same direction. So you can see they both go negative infinity. They're going in the same direction. Any predictions moving forward? If you do an x cubed, what do you think about the arrows? Would they go in the opposite or same? They would do opposite. A fourth would do a same, and fifth would do opposite. Okay, why is that mathematically happening? Because here, if you square a positive number, it goes positive, and you square a negative number, it goes positive. That's doing the same thing. If you cube a positive number, it's positive, and if you cube a negative number, it's negative. That's opposite. Okay, so the next three are new to you. So x cubed is called a cubic relationship, and the arrows will be opposite directions, and the shape is a letter of the alphabet. Anybody guess the letter of the alphabet that would have arrows going in opposite? S. It's not going to be an S, just because S isn't a function. If I put a vertical line through it, it has two boyfriends. Remember? Different letter. You got two different direction arrows. Obviously one has to go uphill, one has to go downhill. Somebody who coaches badminton. An EA at our school that coaches badminton. An N.
That's pretty much what I said.
With the S
Exactly.
sideways. Okay. This end behavior stuff is just going to be the exact same as the one. So what would this look like if it was a negative version of it? Can you try to think about that looking flipped around? So this got flipped, this got flipped. So what would that look like? Okay, to the next, x to the fourth. Okay, this is called a quartic relationship. And the arrow stuff is going to be the same as 2, right? So the arrows will need to be both up or both down. And this is also a letter of the alphabet. W, yeah. Okay, it's kind of like a parabola with an extra bump in it. So if it flips, what would it look like? Okay, and then the last one, x to the fifth, is called a quintic. Quintuplets is having 5 babies at a time, quintic. So it will look the same as number 1 for the arrows. It'll both go in the opposite direction like that. It's very much like a cubic, but you do an extra bump in it. Kind of like a cubic. Okay. Now, that's the basic shapes of stuff. What does this mean? So if you have this as a factor, the x-intercept is going to be at +2. which means your graph is going to cross through. It's going to go through it somehow at 2. Okay, this is a root, but it's squared, so it's doubling. So this time, the x-intercept at 2, it's going to bounce. It's going to bounce at 2. And the last rule here, there's a triple root. And it's obviously still at 2. This is going to be called a flatten. So you're going to flatten out and then go through it. So this, if it happens just once, you just go right through it. If it happens twice, you bounce off of it. And if it happens 3 times, you have to flatten as you go through. Okay, you know how to do this whole unit basically now. This is it. You got your shapes and your 3 rules. That's it. Now you can do anything. Okay, here we go. Number 1. If you were to multiply, what degree would you have? You would have x to the what exponent? How many times did you have to multiply an x? 3. What shape is x cubed? It's going to be like that. Okay, what are the x-intercepts? +1, -2, and +3. What is the y-intercept? What does a y-intercept mean? If x is 0, so what is 0 subtract 1 times 0 plus 2 times 0 minus 3 would equal? So what's -1 times 2 times -3? Did you get a 6 out of that? Okay, so there's my intercepts. I got my labels, 1 tick, 1 tick. And I have to draw this N shape. So it's going to look like this. And some of you might go above this and then down and lower here. That's okay. I'm not looking for precise on this max or this min. I'm not looking for that. Okay? Unless you want to do some calculus stuff. Okay, next one. If you were to multiply all of the x's, x to the what at the end of all this? This would have an x squared in it timesing another x squared. So would you understand that's an x4? Okay, so that means what? Kind of a W shape. The arrows need to both go uphill. So my x-intercepts are going to happen at 1 and -2. But at 1, it got doubled. So what was the thing that happened with the double pattern? It's going to bounce. I'm just going to write myself a little memo there. It's going to do a bounce. then what is the y-intercept? So what is 0 subtract 1 squared times 0 plus 2 squared? Okay, so there's my x-intercepts, my y-intercept. I got some labels on enough. And remembering that at the very end here, my arrows have to be doing that, going up, up. And we're going to have to bounce, and we're going to have to do a bounce. So what is it going to look like? Okay, I'm going to skip. Okay, how many x's get multiplied here? 1, 2, 3, 4. Okay, do you see that? Because this is a squared. 1, 2, 3, 4. And this time there's a negative 2 in the front. So that means what? I'm going to be flipped. So my x-intercepts are at -1, at 2 with a bounce there, and at 3. And then the y-intercept is when the x is 0. Did anybody else get 24 out of that? Okay, I'm obviously not going to draw 24 tick marks. I'm just going to draw you my coordinate labeled. And then I just put 1 tick mark here to show you on that axis that each one is going up by 1. And then I remembered my arrows both need to go down, down when I'm done. Okay, so how can you connect this shape remembering that you have to do a bounce on that one, right? You have to bounce off that one. Can you connect them together then, that they go through, bounce, go through. Okay, and again, yours might look a little bit different on how high you go on your bumps. That's okay. Okay, last graph. How many x's do you have after this is all multiplied together? 4. It's going to be a w because it's positive. So the x-intercepts are at 2 and -2, but this one is a triple. So what do we do special at a triple? We have to do a flatten. y-intercept. Okay, so here's my intercepts. I'm just going to make a note to myself here lightly that I have to end up going up, up. Okay, so we said we were going to flatten through this one. So then I would need to do a pattern like that. That's a flatten. Go through the y-intercept, go through the other x-intercept. So my arrows have to both end up, and I have to flatten through that one. Okay, a couple more and then we're done for today. Okay, find the equation. All right, so now here's what I'm going to do. I'm going to go y equals a, and then I'm going to list some factors. Okay, so here we're going through -2. So I'm going to write the factor x plus 2. Here we went through 1. So I'm going to write the factor x minus 1. And here we went through 3, so I'm going to go x minus 3, bounced, so square. So that was a bounce, so there's my square. Okay, now here is a point. So I'm going to plug that point in. So I'm going to replace x with 0, and I'm going to replace y with 36. What's the goal? We're going to figure out what this a is going to need to be. I already know what about a. Does anybody know one? It's going to be negative, right? Because of the arrows. Whatever this a is, it should be negative. Okay, so I'm going to go 36 equals a, 0 plus 2, 0 minus 1, 0 minus 3 squared. What does all that multiply to? 2 times -1 is -2 times 9, so -18. So a equals -2. So now I just rewrite my equation with the actual a in there. All right, let's try one more like that. Okay, y equals a. Okay, so we have -2, so x plus 2, but there was a bounce on that one. There was a bounce happening there. And then we cross at 4. So x minus 4. And then it gave me a point. So I'm going to now use this to plug in, to replace x comma y. Okay, so here I got 2 plus 2, so 4 squared. So that was 16 times negative 2, negative 32. Everybody's there. So if I divide, what is that a value? Negative a half. And I knew it was negative. Looking at the start of it, it was negative. I knew that right away. So final y equals negative a half, and then your factors, done. All right, very last question. Write an equation for a polynomial with x-intercepts at 5. If your x-intercept is 5, there's your factor, with a multiplicity of 2. X-intercept at negative 1, so the factor is x plus 1, multiplicity of 2. So far, how many x's does this multiply right now? x4, which would be like a w. But I need to get myself a range that goes from negative infinity to 0. So would this go from negative infinity to 0? No, that goes from 0 to up. So what would I need? I would need it to flip. So what should I do here? I need some kind of negative anything, really. Doesn't matter. You could just do negative. You could do negative 3. And sometimes we forget this. How do you make equations? Put an equal sign in it. Okay, but that negative made it flip, which caused the range.